Hello all. In this video, let's have a look at a spur gear design. I'm going to use a simple method to design this gear, and before starting the design, we need to understand certain things about gears. The first one is module. Module gives us the information on the size of the gear. It indicates how big or small a gear is. We have backlash. Backlash is the clearance between two gear teeth. I mean the tooth of two different gears which are in mating. Then we have tooth depth. Tooth depth is the distance between the tip circle and the root circle. The circle passing through these edges is the tip circle, and the circle passing through these edges is the root circle, and the distance between these two is tooth depth. Pressure angle is the angle at which pressure on one gate tooth is passed to the other gate tooth, which are in mating. Pitch point is the point where two gears meet. Here we have pitch point, and the circle passing through this pitch point is nothing but pitch circle. We are going to use pitch circle for the design, and then we have some variables and equations. So for this design we need to create or define some variables, and then we also need to define some equations. Based on these equations we are going to design the gear. Let's go ahead and start the design. So for this design, I'm going to define all the variables first and then start the design process. So tools, to create variables or equations, we need to go to tools and then equations. Here under global variables, I'm going to define some variables such as number of teeth. For this particular design, I'm going to use this value as 25, and module. So I'm going to use module as 1.5 for this. Then we have bore diameter. It's going to be 10 mm. Then we have another constant, which is pressure angle. So pressure angle for gears these days is 20 degrees. Earlier it used to be 14.5 degrees, but now it's 20 degrees. Now it's time to write the equations. So the first equation is for outer diameter or outer circle diameter. Outer diameter. And the equation for this is number of teeth plus 2 times module. So I'm gonna use open parenthesis, number of teeth plus 2 close parenthesis times module. While entering the equation, make sure that you're giving proper spaces so that SolidWorks understands what exactly you meant. And if the equation is correct, you will see this green mark here. Just click OK. You can see the updated value based on the equation. We have pitch diameter or pitch circle diameter, and that is number of teeth times module. Okay. Also we have backlash or simply clearance, and the equation for that is 0.3 times module. Arc length's equation is module times pi divided by 2 plus backlash. So arc length, open parenthesis and then open parenthesis, module times pi divided by 2 plus backlash. So we are getting an error here, so let's have a look at what's going wrong. So we forgot to include a parenthesis, a closing parenthesis. Now I think it's okay. Yeah, as you can see, the value is updated here. Fillet radius, that is 0.38 times module. And the last one we have here is tooth depth. So for tooth depth, we are going to use an if condition because tooth depth changes with change in the value of module. If the value of module is 1.25 or less than that, then the tooth depth is going to be 2.4 times the module. If it is more than 1.25, then the tooth depth is going to be 2.25 times the module. So to satisfy that condition, we are going to use an if statement. Or simply, if you know the value of your module, let's say if you're going to use module of more than 1.25 all the times for your design, you can simply use 2.25 times module as the value for tooth depth or as the equation for tooth depth. Or if you are not sure that whether you're going to use module of greater than 1.25 or less than 1.25, you can simply use this condition here. I'm going to use this condition. So tooth depth condition is if module less than or equals to 1.25 comma module times 2.4 comma, which means else module module times 2.25. Okay, now because I took the value as 1.5, SolidWorks used 2.25 times module as the formula for this tooth depth. Let's say if I'm going to use 1 here instead of 1.5, you can see, sorry, if I'm going to use module as 1, you can see the change in the value of tooth depth, which is 2.4 times module, which is 2.4 again. So I'm going to change it back to 1.5, and by this you can simply say that everything is linked here. Click OK. Now it's time to start the design. As we are done with defining all the variables and equations, it's time to start the design. The first thing I'm going to do is I'm going to use front plane and I'm going to draw two circles. The first circle is for bore diameter or simply the bore, and the second circle is outer circle. Smart dimension. Here, to link the dimension to a variable, simply press equals to first and then go to global variables. This one is bore diameter, so I'm going to enter bore diameter here and click on OK. If you see this sigma mark here, that means the dimension is linked to the variable. If you don't see it, that means that it is not linked. Click OK. You can see this red mark here if it is linked. And smart dimension, this one is going to be outer diameter equals to global variables outer diameter, or simply you can type the details here, like you can simply type outer and then you can see the options. Click OK. So these two are linked to the variables. Okay, as the sketch is fully defined, I'm gonna go to features and use extruded boss or base, and I want the thickness of the gear to be 10 mm, so I'm gonna click OK here. Now we have the basic structure, which is a cylindrical structure for the gear. All we have to do is we have to cut the teeth. Now to do that, go normal to the surface. Now I'm normal to the surface. I'm gonna draw a center line now. So I'm gonna draw a center line to the quadrant point, And now I'm gonna draw three different circles. The first circle is the root circle, the second one is the pitch circle, and the third one is gonna be outer circle. You can also use convert entities for the outer circle, and then you can use offset entities, or you can simply uh, copy the circles and give distance between them. There are a number of ways to do this. Go to smart dimension. So we are going to start from the outer circle, as the circle's diameter is equals to outer diameter. I'm going to link it to outer diameter. Okay. Then we have pitch circle. We also have variable for pitch circle diameter, so I'm going to use that variable, which is pitch diameter. Okay. But we don't have any variable for the root circle, which gives the dimension for the root circle, but we have distance between the root circle and the tip circle as tooth depth. So I'm going to use that distance to fully define the sketch. So this value is going to be tooth depth equals to tooth depth. Okay. Now the sketch is fully defined. I'm going to make this a construction circle. Now I'm going to draw a circle, sorry, an arc here, somewhat like this. And mirror entities, for mirror about, select the center line here. Okay. I'm going to draw a center line between the arc and this center point of the circle, and I'm going to draw another center line which is coincidental to this arc. From anywhere on this line, draw a line which is coincidental to the arc. Now it's time to add relations. The first one is going to be the center point on this arc. Press Ctrl and select this line, make it coincident. Okay. And then we have this arc and this line tangential to each other, and this arc is tangent to this line here. Now here we have the pressure angle, the angle between this line and this line. Smart dimension. So we have the angle between this line and this line as pressure angle. So I'm going to link it to the variable, global variable, pressure angle, which is 20. Okay. Now trim entities. Using power trim, I'm going to trim all the circles here except this part. Okay. Now the sketch is not yet defined. To make it fully defined, we need to specify the arc length here. So we have the arc length. But if I'm going to select smart dimension and select this arc, it will show us the radius value instead of the arc length. To get the arc length, select smart dimension, select this endpoint here, press Ctrl, keep pressing it, and select the other point, and then select this arc. You can see an arc symbol on top of the dimension. Link it to arc length here. Okay. Now the sketch is fully defined and we have the profile for cut between two teeth. So go to features, select extruded cut, and under end condition, instead of blind, I'm going to use through all, because if I'm going to change the thickness of the gear, it will still cut the whole shape, so, or the whole object. So I'm gonna press OK. Now we have the cut between two teeth. What I'm going to do is I'm going to add fillets now. Keep the constant size fillet selected. Select this edge and select this edge here. And for the fillet radius, press equals to and link it to fillet radius global variable. Click OK. Now that we are done with adding fillets, it's time for us to use circular pattern to get the full gear design. Circular pattern, and for direction 1, select this circle or select this circle. It doesn't matter as long as you're giving the proper direction. So I'm going to select this circle. As you can see, under features, fillet is already selected, so we can see the fillet pattern here. Under the number of instances, make sure that equal spacing is selected and the angle is 360 degrees. For the number of instances, I'm going to link it to the global variable number of teeth. So the reason for linking this is if we change any variable, the whole design will automatically get updated based on the inputs. And for features, first I'm going to click OK. And for features, as fillet is already selected, we need to select cut extrude as well. If fillet, let's say the fillet is not selected here, just select fillet and cut extrude so that you can see the pattern. Click OK. Now we have the gear design here. I'm going to specify material now. Let's say this is a plastic gear, so I'm going to use ABS plastic as the material. ABS, apply, close. Let's go ahead and change the values for the variables. I'm going to go to equations. So let's say uh, the number of teeth is 40. As you can see, the number of teeth is updated here and the module is still the same. If I change the module here, this will get automatically updated. So I'm going to make this module as 1 and hit enter. When I hit enter, you can see the change. The gear size is reduced because we are using a lesser module value. If I make it somewhere around like 3, you can see a bigger gear here. And for 1.25, you can see a smaller gear. Changes we are making here, it will change over here as well. So let's go ahead and change the pressure angle here. So I'm going to make it 14.5. As you can see, with change in angle, we got a small change here. So I'm going to change it back to 20. You can observe the changes here. And if I make it 14.5, it's getting broader. I'm going to change it back to 20. And bore diameter, it doesn't matter. If I just change it to 20, this is going to get increased. So this will get increased. I'm going to change it back to 10 and this to 1.5. Okay. So by following this simple method, you can create a spur gear. Now we are done with the cut profile. So in case of spur gear, you can simply use extruded cut, and under end conditions you can use through all in both directions, and then you can use circular pattern under features. But as this is helical gear, we need to define the cut path as well. So before doing that, I'm going to extend this cut profile in the y direction. To do that, I'm going to select this outer edge and select offset entities, and here I'll give a value of 1 mm and I'm going to click OK. Now if you click on this drop down of trim entities, you can see extend entities. Select this arc so it will get extended till that point, and select this arc and click on trim entities and trim the rest of the thing. Now this is not fully defined. To fully define this, just click on this and click on fully defined sketch and calculate. So it shows over defined. That is fine. Just click on this over defined dialog over here at the bottom and click on diagonals and just add this diameter. That will do the work. Sorry. So click on this over defined diagonals, accept, click on OK, then display or delete relations, click on fully defined sketch, calculate. And now the sketch is fully defined, and I'm going to change this to construction geometry. So now we have the cut profile, and to do the tooth cut, what we need to do is we need to create the path for the cut. To do that, I'm going to use top plane, and here I'm going to draw a line, something like this, and I'm going to select the midpoint and the origin point and make it coincidental. Using smart dimension, I'm going to give an angle here. So I'm selecting this line and this point. Now when you select the line and the point, you can see arrows in 4 directions, and I'm going to select the top direction, like upward direction, and the value is going to be 30 degrees. Now this line is fully defined, and I'm going to exit the sketch. If you go to isometric or trimetric or any other view, you can see that the line is over here at the center, but I want this line, which is going to be the path for the cut, to be on the surface. To do that, I'm going to use project curve, which is under curves. And under project curve, you can see projection type. The first one is sketch on faces and the second one is sketch on sketch. So we are going to use sketch on faces, and this is the sketch, and the face is going to be this. Sketch 8 is already selected, which is this line, and the face is going to be this. As you can see, this line is projected onto this face, so I'm going to click OK. We can use swept cut over here and we can give this as the path, but we can see a lot of uncertainty in the cutting. So to have a proper cut, we are going to use lofted cut. To do that, we need to have two more profiles, one on this face and one on the back face. For that, I'm going to select sketch 7 and this face, and then I'm going to go to insert. Here I'm going to select derived sketch. As you can see, there is a sketch on this face. And now I'm going to select this point and this line and add a relation which is Pierce point. Also, I just want it to be fully defined, so I'll just click on fully defined sketch, calculate. Okay, now this sketch is fully defined. Now I'm going to exit this particular sketch. Again, I'm going to follow the same method. Sketch 7 I'm going to select, which is the base sketch, and then I'm going to select this face, back face, insert, derived sketch, Now I'm going to select this point and this line, sorry, not this line. This line and the PS relation here, and under display or delete relations I'm going to select fully defined sketch, calculate. Okay, now the sketch is fully defined. As you can see over here, I'm going to go to isometric view. I'm going to exit the sketch. Now I'm going to use this feature which is lofted cut. For profiles, I'm going to select these three profiles and right click selection manager. So I'm going to select only this profile. Okay, then this, then this. Instead of using guided curves, I'm going to use the centerline parameters because we have a center line here. So this line is going to be the center line. Okay, so now we have a proper cut and I'm going to use circular pattern to create the teeth. But before that, I'm going to add fillet here. To do that, I'm going to use fillet and under fillet radius, I'm going to use the fillet radius value which we have, which is 0.57, and items to fillet. I'm going to select this one and this edge. Okay. Now click on this drop down and select circular pattern from features tab. Under direction 1, I'm going to choose this boss extrude and the angle is going to be 360. Under number of instances, I'm going to use this global variable which is number of teeth. Click OK. Now features and faces, I'm going to select fillet 1 and cut loft 1. Okay. So now we have a proper helical gear here. And, I'll show you why we are using equations, because when we use equations we can change the size of this very easily. I'm going to go to equations, manage equations, and here if I change the number of teeth to, let's say, something like 80, enter, you can see there's a change in the size. So we can simply change the size just by entering the value, and we can also change other values. Let's say if the module is something like 1.25 here, 1.25, the size will be reduced, 1.5. And if it is for a bigger shaft, you can change the bore diameter as well. Let's say 20. You can observe it over here. If you can't see any change in the model, you can simply click on rebuild by closing this, as automatically rebuild is selected here, so you can see the changes immediately. If you don't see that, just try to click on this, just try to check this particular option, and if it is not working still, just close this and click on rebuild option which is over here. And let's change this number of teeth again. Let's make it something like 25. We can see something like this. In this video, I'm going to design this straight gear rack. We have top view and front view. The length of this gear is 164 mm and the width is 16 mm. The overall depth is 20 mm, whereas the depth of this or thickness of this gear is 12 mm. The part is made of galvanized steel. The unit system we are going to use is mmgs. So let's go ahead and design this. For this part, I'm going to start the design from top view. First, I'm going to draw a rectangle with 164 as length and 16 as width. Rectangle. Okay. Smart dimension. This is going to be 164 and this one here is 16. Okay. Now I'm going to use extrude boss or base feature and I'm going to extrude it for a thickness of or depth of 12 mm. Features extrude boss or base. The depth is 12 mm. Okay. Now I want to add the cylindrical structures here and the extrusion depth is 20 mm. The diameter of this cylinder is 16 mm, which is same as width. So right click on top surface, select normal to, sketch, circle. The center is this, the midpoint of this edge, and draw a circle till it meets the end point here. Okay, and I'm going to draw another circle just like the first one. Okay, as you can see, it is fully defined because it has proper endpoints and the diameter is 16 mm. We don't have to mention any dimensions here or give any smart dimension. Go to features. I'm going to use extrude boss or base. As you can see, it is getting extruded only in one direction, but as per the design, we need it in two directions. And here, the distance between this face and this face is 4 mm. The total thickness of the gear is 12 mm. So 12 plus 4, it is 16. So we are left with 4 on the upper side. So what I'm going to do is, I'm going to use direction 2 for this. So this is direction 1 and this is direction 2. For direction 1, we need only 4 mm above the surface. So I'm going to make it 4. Make sure that merge result is selected. And for direction 2, I'm going to give the value as 16. Okay. So now we have the basic structure. Now we are left with adding holes and the teeth. First I'm going to add holes here. Right click on the surface, select normal to. The dimension of this hole is 7.50, which is the radius, which is the diameter. Sketch. Select this face and with this as center, draw a circle. Okay. Smart dimension. This is 7.5. Okay. I'm going to draw another circle here. And the diameter of this circle is 7.5. Okay. Now I'm going to use extruded cut feature. And for end condition, I'm going to use through all. Okay. So we added holes here. Now it's time to add the teeth. First I'm going to draw this shape and then I'm going to use extrude boss or base feature to get this, and later I'm going to use linear pattern to get this number of teeth. I'm going to use front view for this or front face. Select normal to, and I'm going to go to sketch, line. Here first I'm going to draw a horizontal line and then I'm going to make this shape. Now I want to add a relation between these two lines here. I'm going to make them equal. Okay. Smart dimension. The width is 2 mm and the height of this tooth is 2.5 mm. From here till here it is 2.5. Also we have an angle here that is 40 degrees. So select this line and select this line. It's going to be 40. And the last dimension that we need to add is this. So the distance between this point and this edge is 18. So I'm going to select this point here, and I'm going to select this edge, and it is 18. Now the sketch is fully defined. What I'm going to do is I'm going to go to features. I'm going to select extrude boss or base, and the extrusion should be in reverse direction. So I'm going to select reverse here, and the depth should be 16, which is the width. Okay. Now we are done with adding one tooth here. What I'm going to do is I'm going to use a linear pattern to pattern this on this face. So for direction 1, I'm going to select this edge. As you can see, we have an arrow here showing the direction. If it is in reverse direction, select this button or select this option here. It will change the direction. And for spacing, as you can see, the spacing is 6 mm. So enter the value as 6, and the number of instances is going to be 24. Under features and faces, for the first one is feature. So open this design tree or expand this design tree and select boss extrude 5, which is the tooth. Okay. Now we are done with designing the gear. We need to assign the material to check the mass. Right click on the material, edit material. The material we are going to use for this part is galvanized steel, and the units is MKS. Apply. Now to check the mass, I'm going to go to evaluate, mass properties. As you can see, the mass is 300.19 grams. Save the file and exit.